Hey there, Prof. Aram here, and in this video we're going to go over the special case of dividends that are growing at a constant rate, which is the Gordon growth model or constant growth model of stock valuation, which is one of the most popular models of stock valuations, and that's what we're going to focus on in this chapter. Okay, so let's get to this. In the constant growth stock, we are assuming that the stock dividends are expected to grow at a rate of G or growth rate forever. So this helps us to estimate or forecast the future cash flows of a stock. So we know that next period, our dividend is going to be the dividend that was just paid, the past dividend, times 1 plus growth rate raised to the power of 1. 2 years from today, or 2 periods from today, we know that the dividend is going to be our dividend that was just paid times 1 plus the growth rate raised to the power of 2, and so on and so forth until you get to dividend at time t. As you know, the way to go ahead and find a price is just finding the present value of these cash flows. So we do d1 over 1 plus the required rate of return for the stock raised to the power of 1 for the period 1. Find the present value of the dividend in year 2 like this, and dividend in year 3 like this. And we know that dividend in year 1 is d0 times 1 plus c raised to the power of 1, and so on and so forth. So with a little bit of algebra and simplification, we get to this formula, right? This is the growing perpetuity formula. In this case, the assumption is that you're going to receive dividends forever. So it's like a perpetuity. But unlike perpetuity, your cash flows are not constant. Your cash flows are growing at a constant rate of G. So the present value of a growing perpetuity is going to be the dividend of the next period over the difference between the rate of return and the growth rate. A key point here is to notice that to find the present value of the stock, to find the price of the stock, you need future dividends. You need the future dividends of the stock. So if the question is telling you the company just paid $2 in dividends, that is in the past. That's irrelevant for pricing. To find the price, you need the future cash flows and find the present value of the future cash flows. So the subscript is very important here. I want you to pay attention to it. So for price today, you need dividend in year 1 over the difference between R and G. Or you can write it this way: if you have D0, or the dividend that was just paid, that's in the past, times 1 plus the growth rate over R minus G. So these two are the same thing. You can actually generalize this for pricing of the stock at any point in the future. At any point in time, price would be the dividend of the next period over R minus G. So if you want price in year 7, you need dividend in the next year, year 8, and then the denominator would be the same. So you always need the dividend of the next period to find the price. So let's look at an example. Suppose Biggie Inc. just paid a dividend of 50 cents per share. It is expected to increase its dividend by 2% per year. The assumption is that you have a constant growth rate forever, but 2%. If the market requires a return of 15% on assets of this risk, how much should this stock be selling for today? So let's look at our numbers here. This 50 cents, what is it? Is it dividend next year, or is it in the past? So because it was just paid, This is your D0. So to find the price, you need to find the dividend of the next year, which is D0 over 1 times 1 plus G over R minus G. So you will have 50 cents times 1.02 over 15 minus 2. So you should be getting 392 for this stock. So it's very important again. This is in the past. Past cash flows are irrelevant for our pricing. You need to find the future cash flow, which is next year's dividend or next period's dividend, by multiplying your D0 by 1 plus the growth rate. Let's look at another one. Suppose TB Pirates Inc. is expected to pay $2 in dividends. So since they are expected to pay this in 1 year, this would be your D1. What is the price if the dividend is expected to grow at a rate of 5%? So growth rate is 5% and R is 20%. So again, P0 would be D1 over R minus G. It would be $2 over 20 minus 5, which would be $13.33 for the price of this stock. And let's look at another one. Gordon Growth Company is expected to pay a dividend of $4 in the next period, and dividends are expected to grow at 6% per year. The required rate of return is 16%. First of all, what is the current price? So the current price, P0, is D1 over the difference between the rate and growth, this required rate of return and growth rate. So it says expected to pay this dividend in the next period. So this is your D1. So 4 over 16 minus 6. That should give you $40 for the price of this stock today. What is the expected price in year 4? So if you want So if you want price in year 4, you're going to need the dividend in year 5. You need your D5. How can we find D5? You already have your D1. You need to compound it for 1, 2, 3, and 4 years. So P4 would be your D1 times 1 plus growth rate raised to the power of 4. Denominator stays the same, so you'll have $4 times 1.02 raised to the power of 4 over 16 minus 6. So in this one, you should be getting, let me just calculate it. Let's just go ahead and so for this one, you should be getting 1.02 raised to the power of 4 multiplied by $4 divided by 10%. So you should be getting 43.3. $3, which is the price in year 4. You know what? I think I made a mistake here. This should be, I don't know why I used 2% for growth rate. 6%. So let's do it again. I'm just gonna erase it. So 1.06 raised to the power of 4 times 4 divided by 10%. You should be getting 50.05. We are going to draw a conclusion here that's very important. If you pay attention to this one, this part, this is nothing but your P0, price today. See, you already have it here. So D1 over R minus G is your price today. So the conclusion that we can basically draw from this practice is that price in the future, at any point in the future, is going to be price today times 1 plus the growth rate raised to the power of T. In other words, your price is growing at the same rate as your dividend. That's why later on we'll see that we call this as the capital gain yield, or the rate at which your price is growing. So that's the conclusion that we want to draw from this practice. Your price is growing at the same rate as your dividend. So this constant growth model or dividend growth model or Gordon growth model conditions are that dividends are grow at a constant rate of G forever. The price is also expected to grow at a rate of G forever, as we just saw. Expected dividend yield is constant. I'm going to talk about the dividend yield. It's basically D1 over P0. And the expected capital yield is also constant and equal to growth rate. And your rate should always be greater than your growth rate. Your rate of return should be greater than your growth rate. And the reason is that if the growth rate is greater than your rate of return, you're going to end up with a negative number in the denominator and negative price, which doesn't make sense. If the growth rate is the same as the rate of return, then you will have 0 in the denominator, and this ratio would be undefined. So that's why we are going to assume that the rate of return is greater than the growth rate. I hope you find this video useful, and thanks for watching.